This is 2834. It draws a basic RC circuit with the battery down here and the resistor here and a switch and a capacitor. The battery has 30 volts, it gives 30 volts. The resistor is a mega ohm and the capacitor is 1 microfarad. So it has three questions. The first is, what is the RC time constant? Or what is the time constant? Well, it's often called the RC time constant because it's R times C. So tau, so what we usually label it, is R times C. So it's 10 to the 6 ohms times 1 times 10 to the minus 6 farads. I'm sorry, it's 5 microfarads. That's not enough. 5 microfarads. I won't start over. There we go. So 10 to the 6 times 10 to the minus 6 is of course 1, so we're just left with 5. So this is 5 seconds. Time constant is 5 seconds. Let's see, then it says after flipping the switch, what is the maximum charge on the capacitor? So when we close the switch, current will flow like this. It'll charge up this plate, draw negative charge on that plate. So by saying the maximum charge, it means that time equals infinity. If you let this thing charge up and charge up and charge up, what ultimately will be the total charge. So there you don't need the time behavior, you just need to know what will eventually do. So eventually you'll reach the point where you're at 30 volts here and 0 volts here. If you let it go long enough, there'll be no more current and all the voltage drop will be across the capacitor. No current means no voltage drop across the resistor. So you have to go from 30 down to 0. So if that's the case, then you just apply the standard formula, 5 times 10 to the minus 6 farads times 30 volts gives you the total amount of charge. So 5 times 30 is 150, and then 10 to the minus 6 is micro. So it must be 150 microcoulombs. And then C, the last question is, after 10 seconds, what is the current? Okay. So now we do have to think about how the current flows in time. And we know that when you close the switch, you'll instantly get a big current and it'll slowly die down as the capacitor charges up. And we know it goes like this. I of t is I naught e to the minus time over tau. All right. And so after 10 seconds, we just have to plug in our values here. So I naught is what it has immediately. So when you close the switch, right away, there's no voltage drop here. All the voltage drop is across the resistor. So you just say the EMF over R. And if you recall our formula, I actually did have the EMF over R. So it's 30 volts over 1 mega ohm. Right, so that's 30 microamps. And then E to the minus, and we're talking about what, 10 seconds. 10 seconds here, 5 seconds here, that's e to the minus 2. So you just stick that in your calculator. 30 microamps times e to the minus 2 is 30 microamps divided by e squared, however you want to write it. Finally, though, you get that I, at 10 seconds, put it in your calculator, is 4.05 microamps. And that makes sense. It's lower than the original 30 microamps, and it's making its way towards 0.